a very powerful operator which has given rise to many tricky questions in the world of bit manipulation. Yes, and that is XOR. It's a very interesting operator. So this is XOR operator. This is also called as exclusive OR. Yeah, and this hat is the representation for it. This is called as hat operator. This key is there in your keyboard. You can check that. Okay, so you can take XOR of A and B, and again this thing happens at the level of bit. Okay, so if let's say there are two bits, 1 and 1, then the XOR will be 0. 0 and 0, the XOR will be 0. If it is 1 and 0, then it will be 1. If it is 0 and 1, then it will be 1. So what is the rule of thumb? If the operands are different, then the result is 1. And if the operands are same, then the result is 0. Right? And now you would just use your brain in what kind of terms would it be important. It would be extremely important in the terms that, let us just assume that there are two numbers. Okay, there are two numbers, and you simply want to check whether their ith bit are same or different. Okay, whether their ith bit are same or different, then this thing can help you a lot. This XOR thing can help you a lot with that. Okay, we'll see such questions. For now, tell me one thing. If I take XOR of 7 with 7, what will be the result? If you take XOR of a number with the number itself, the result will definitely be 0. Why? Because what is this 7, 1, 1, 1, and what is the 7, 1, 1, 1? So obviously, if these both numbers are same, this bit pattern will be a carbon copy of this bit pattern. So this will be same as this. So that in the result, position here will be 0. Similarly, this will be same as this, 0. This will be same as this, here, 0. So that is the rule over here, right? So if you take the bitwise, if you take the XOR of a number with the number itself, then the result is 0. Okay, cool. Another question is, if I take XOR of a number with 0, what will be the result? The result will be the number itself, and this should be very easy to guess, because just see, no matter what is the binary representation of x, 0 can always be written as 0, 0, 0, 0 by padding some initial zeros. Now, if there was a 1 over here, then for sure there is a 0 over here, because this entire thing is 0. So the result would have been 0. And if there is a 0 here, obviously there is a 0 over here, the result of that will also be 0. 1, 0, 1, 1, 0, 1. So that being said, if you take XOR of a number with 0, the result will be that number itself. Let's talk about certain operators. Let's talk about addition. If I do A plus B plus C plus D, does the order of addition matter? Does it matter which pairs do I add first? It doesn't matter. You can first add this, then you can add this, then you can add this. Or you could first have added this, and then would have added this to this, and then would have added this to this. Right? Is the same thing true with XOR also? Just use your brain and think, would it be true or not? It will be true. It will be true. Just think of it in this way. That you have a number 1, 0, 1 XORed with 0, 1, 0 XORed with 1, 1, 0. This is what you are doing. Okay, and let's say one more, 1, 1, and then 1. Then first you would play around with this bit position. So 1, 0, 1, 1. So you are talking about 1, 0, 1, 1. 1, 0, and then 1 and 1. So what will be the result of this? Can somebody tell me? What will come over here? Let's take a look. So if you take 1 XOR 0, what will be the result? What will be 1 XOR 0? It will be 1. And what will be 1 XOR 1? It will be 0. And what will be 0 XOR 1 again? Again it will be 1. Even if you would have taken it sequentially before telling me your answer, you would have seen that the answer is coming out to be 1. But my intention was to tell you that the order doesn't matter. Why order doesn't matter? Because whether you take XOR of this, and then take the XOR of that with this, it doesn't matter. You can first take the XOR of this with this also. If you perform 1 XOR 1, it will be 0, right? And now you have 0 XOR 0 XOR 1. So many 0 XORs will always result to 0, and that 0 XORed with 1 will be equal to 1. So basically XOR operator, you don't have to worry in which order you have to perform the value of XORs. Okay. Tell me one more thing. What will be the result of 5 XOR, 5 XOR, 5 XOR, 5? What will be the result of this? Yeah, because 5 XOR 5 is 0, 5 XOR 5 is 0, and 0 XOR 0 is again 0. Okay, what would be the result of 5 XOR, 1 XOR, 5 XOR, 5 XOR, 5? What will be the result of this? It would be 1. Had there been 6, the result would have been 6. Why? Because 5 XOR 5 XOR 5 XOR 5 would have been 0, and 0 XORed with 6 would have given me 6. So if let's say there is a number p which comes even number of times, in an array, and you are trying to take the XOR of entire array, then what will be the contribution of p? It will be 0, right? Because p XOR p till even number of times would result you to 0. And if let's say it came odd number of times, then what would be its contribution? Then its contribution would just be p, because any odd number can be written as some even number plus one more instance of that number. So all those even branch would have resulted 0, and that 0 XORed with one more p would have resulted in p itself. Cool. So these are important things about XOR. Very good.